Now we talk about the static friction. Static friction is not fixed, you know. Static friction is not fixed. Now, why I say this static friction is not fixed? Let's say we have an object. Let's say we have an object, a cup,
right?
right? A cup. I apply a force to push this cup. It is not moving. I apply a bigger force, it's still not moving. I apply a bigger force, then it is about to move. Extra a little bit, then it start to move. So you see that when I apply a small force, the friction is very small. I apply a bigger force, the friction becomes bigger. And to I keep on applying the increasing the force until the friction cannot stand and it start to move. So this frictional force is actually not fixed. It depends on how much force you are applying. If you're applying a small force, then they will oppose with a small force. You apply with a bigger force, they will oppose it with a bigger force. So it's not fixed until a certain limit. Until a certain limit, at a critical point, they start to move. That is the maximum static friction. So the first one is the small static friction. Second one is a bigger static friction. And the third one, finally, when it is about to move, that will be the maximum static friction. So F, you look at this one, static friction force. This static friction force is actually changing all the time. It depends on this applied force. The applied force is FAPP. It is different from the FNET. FNET is the net force. FAPP is the applied force. Applied force is how much you are pushing, but it is not the excess force. The excess force,
Okay.
you have to take the difference between the two forces, and that will be the net force. Okay, that will be net force. But this one is just you apply only. It is not the net force. How much you are giving it. Okay, can you read this one here? Applied force.
Um,
F applied.
Applied force is exerted against an object such as this trash can. The trash can typically doesn't move unless the force exceeds some critical value. The critical value is the maximum static friction force. The magnitude of the static friction force Fs acting on the object at rest, the magnitude of the frictional force against the applied force.
Okay. Now, so this here, they are actually referring to the diagram, the trash can here and here. Okay, they're actually referring the
Mhm.
trash can. For small applied force, I'm reading from here. For small applied force, the magnitude of the static frictional friction equals the magnitude of the applied force. So when you put an applied force here, the F with an arrow at the top, and you push it to the right hand side, the friction, the static friction opposes it in towards the left hand side. So they oppose.
Okay.
And it is not the maximum force yet because it is not moving now. It's not moving, so it's not the maximum force yet. So you apply a bigger force F towards the right, there will be a bigger static friction towards the left. The value has increased. So when it is about to move, it is the maximum static friction. It is the maximum static friction, and it's denoted by this here as static and maximum with the max there. Okay, if you don't put the max there, that means it has not reached the critical value yet. It is not about to move. Okay, then the second diagram, when the magnitude of the applied force exceeds the magnitude of the maximum force of static friction, the trash can breaks free and accelerate to the right. Okay. Now,
Okay.
what is the relationship between this Fs maximum and Fk, right? We look at this diagram again, right? Magnitude of static force Fs acting on an object at rest. So this static friction can be anything between 0 and the maximum static friction. The
Mm-hmm.
static friction is not fixed. It can be anything between 0 and the maximum value and the maximum value. And this maximum value is actually the mu s. It's not mu k anymore. Mu s, right?
Right. Yes.
Multiply with the normal force. So we look at the first case here. The first case, the applied force, you give it an applied force. It is not moving. So we say that this applied force, the frictional force is still less than the maximum, right? Still less than the maximum. Then you increase it until it is about to move. It's about to move. Then it is equal. It is equal. The applied force is equal to the maximum frictional force or the maximum static friction. But when the object is moving, when you push and the object start to move, it's no longer the static friction. It is the kinetic friction that is opposing the object. And this
Right.
kinetic friction is mu k multiplied with n. Okay, it's mu
Okay.
k multiplied with n. So from the graph, we can see that as you increase the applied force, from 0 until the dotted line here, 0 until the dotted line here, the
Mm-hmm.
static friction will increase. As you increase the force, the applied force, the static frictional force increase. As you increase, they will increase. They will increase until a maximum level here at this point here, right? At the edge here. At this point, it is the maximum static friction. Still not moving yet. When the object starts to move, the frictional force actually decreases. So when they start to move, that frictional force is the kinetic friction. And this kinetic
Okay.
friction is less than the maximum static friction. It is less than the
Okay.
maximum. So that's how we interpret the red line. That's how we interpret the red line.
Okay.
From the straight line represent the static force until the maximum point. But when it start to move, the friction will drop, and this level is the kinetic frictional force. So there is the relationship between all these static and kinetic friction force.